Hi everyone. All right, today we're talking about Unit 9, Day 3 notes, triangle relationships and circles. So we're going to learn a few more rules, 3 more rules that we can apply to our list of things to look for when we're trying to solve some circle, angle, arc problems. All right, so the first one, we're just going to start off with a new rule. Take a look at this picture. So remember, I've been trying to train you to look for the center of the circle. Because if you have the center, we could have diameters, we could have radii, we could have central angles. There are no segments coming off of that. All right, so then I've been trying to train you to look for inscribed angles. If you look at each point, check to see if there's 2 segments coming off of each. That is not the case here. So if you look at this problem, do you see an X? And I have a 1 in there. So there's vertical angles. So that angle we know is going to be congruent to this other angle. So you already know that. But there is a relationship between the measures of these angles and their arcs. So again, if you take an angle and follow it out, it creates an arc. Same over here. So if I were to take, I'm just going to highlight my X, my vertical angles. I'm making those segments longer. 1, if you kind of follow it out, it goes out to arc AC, and the angle 1, technically on the other side, if you zoom it out, it goes to arc DB. There is a relationship. There is a formula. And the formula is the measure of the angle is half the arcs added together. So it's actually a theorem. The measure of the angle formed inside a circle by 2 intersecting chords is equal to half the sum of its intercepted arcs. So that is actually the theorem. This is something you have to look for. Look for vertical angles, look for an X. And then it is this formula that we are going to be using. So you add the 2 arcs, divide them by 2, and you get that angle measure, which is then vertical to the angle measure across from it. So you add the arcs, divide by 2. All right, so you can kind of think of this as, you know, this angle's inside the circle. You're going to add the 2 arcs and then divide them by 2. You know, the angle you've been added in. I don't know, think of like you and you're inside your circle of friends. You've been added into the group. So we're going to have a similar formula later where we're subtracting. So it's same formula but subtracting. So if you're inside the circle, you're in your circle of friends, you've been added into the group. That's how you can remember which formula are we going to add, which one are we going to subtract. Now, you could memorize that formula and then it's very easy to use. Or there's a completely different way. You don't really ever have to use this formula. We could take our picture and draw inscribed angles. We could make triangles. If you were to connect line segment AC, you now have a triangle here, and we know all the angles in the triangle add up to 180. But by doing this, you have created an inscribed angle. So if we knew arc AD, you could find the measure of that angle. By putting this here, you also have an inscribed angle going out to arc CB. So if you knew that arc, you could find angle A. And then these angles add up to 180 degrees, and then you could find your angle 1. Same thing here, you could connect B to D. You would now have an inscribed angle going this way. So if you knew that arc, you could find the measure of that angle, and you've created an inscribed angle going to arc AD. So there are different ways to do these problems. So it's completely up to you. So you could look for vertical angles, the X inside, and use this formula, or you can draw line segments in to make triangles and use your inscribed angles and your arcs. It's completely up to you. It's whatever your brain sees. But just remember, you know, between any 2 points, you can always connect them and make one segment. That's a rule. Between any 2 points, there exists one line. So it's always legal to add in extra segments in a picture if you wanted to. All right, so let's try using this. Given line segment AB and line segment CD are chords drawn inside the circle. If the measure of arc AC is 20, so arc 20 degrees, I'm going to leave out the degrees and put 20 in the picture, and the measure of arc BD is 100 degrees. Now notice I did not give you the center of the circle. It's not identified, so you cannot assume this is a diameter nor that. Now we have another piece of information. The measure of arc AD is 200. Now, I don't know if you need to draw like kind of line, like arcs here so that you know it goes from A all the way to D. All right, we need to find the measure of angle AEC. AEC. So you could ask yourself, is that a central angle? The answer is no. Is it an inscribed angle? The answer is no. You could now ask, does that angle come from an X? That answer is yes. So you could use the theorem that this angle is going to be this arc plus that arc divided by 2. You could do that. So it's going to be 20 plus 100 divided by 2. All right, so you get 120. 120 divided by 2, you get a 60-degree angle. So that's one way to do it using the formula. It's kind of the fastest way. I mean, I could show you the other way. I'll do it in pencil. If you were to connect line segment AC, you have now created C as an inscribed angle to that 200-degree arc. So this inscribed angle would be 100. Now, by creating that segment, you've created an inscribed angle at A, which is going to be half of arc CB. We don't know arc CB, but you know the other three. So if you were to add these up, 200 plus 100 is 300 plus 20, you have 320 degrees. We know all the way around is 360 degrees, which means there are 40 degrees here. And now that inscribed angle to the 40 degrees is 20 degrees. And now you can use the fact that all three angles in a triangle add up to 180. So far you have 120 degrees. You need 60 more. So it's kind of more math drawn in the segment, but you get the same result. So it's up to you. All right, the measure of angle DEB. Well, I just learned, we just solved this angle 60. Remember, anytime you find an answer, put it in your picture. It is vertical to angle DEB, so angle DEB is 60 degrees also. Okay, find the measure of angle CEB. CEB. Well, I'm seeing different relationships. You could think about that comes from an X. And if you zoom it out, it's going to be this arc plus it's vertical to this arc. You could add those two arcs and divide by 2, but originally we did not have that arc. So again, you would have to first use the fact you have 360 degrees, solve for that missing 40. You could do 200 plus 40, divide that by 2. You're going to get 120 degrees. My brain also sees here's a straight line, there's a linear pair. 60 degrees and the angle next to it are going to add up to 180. So 180 minus 60 gets you that same 120 degrees. Or you could have done the 200 arc plus the 40 arc divided by 2 will get you that same 120 degrees. So after a while, there's more than one way to get an answer. Find the measure of arc CB. So again, it is asking for that. Probably the easiest thing, like we did earlier, take your 200 degrees plus your 100 degrees plus your 20 degrees, add them all up, you get 320, and there's 360 degrees in a circle. So when you subtract it, you're left with that 40 degrees. You could also use our new formula backwards. You could say, well, I know my 120 degree angle is going to equal the 200 degrees plus my missing arc divided by 2. And you could solve this. So this is an alternate way. If you multiply both sides by 2, you're going to get 240 equals 200 plus x. Subtract your 200, and there's that 40 again. So like I said, the more tricks you know, you have different avenues to follow. You could do a problem different ways. But again, every time you solve for something, you should be able to give me the reason why. All right? So here's that other rule I was telling you about. Okay, check out all these pictures. Do you see now that we have an angle outside the circle in all 3 cases? So we have now the measure of an angle formed outside a circle by 2 intersecting secants, or secant and a tangent, or 2 tangents. All 3 cases, the angles outside the circle. It's that same formula, but you subtract the 2 arcs. So let me help you to see this. So angle B is outside the circle. I'm extending those. It hits the circle and creates arc DE, and it creates arc AC. You can clearly see the measure of arc AC is longer. So you need to take the measure of that longer arc, subtract the measure of the smaller arc, and divide it by 2. Same thing in all 3 cases. Here's angle B. If you kind of make these a little bit longer, it's a little bit easier for our brain to see the arcs. You're going to take the measure of arc AC, subtract the measure of arc AD, divide it in 2. Same thing here. You are going to take the measure of this major arc, ADC, subtract the measure of arc AC, divide it by 2. So, same formulas. The first one you add. If the angle's inside the circle, you're in your circle of friends, you add the arcs, divide by 2. In all 3, if you're the angle, you are outside the circle, you've been subtracted away from your circle of friends. So you subtract the arcs, divide by 2. Now again, you could look for an angle drawn outside the circle and memorize the formula, or you can draw on line segments to make triangles and use inscribed angles. So line segments you could create would be like, for example, connecting line segment CD. Now you have an inscribed angle. You have a triangle over here. By connecting that angle C, down here is an inscribed angle. And then you can find like different measurements to your arcs and different measures for the angles of the triangle. So there's different things you could do. You know, you can connect different line segments, make different triangles. Or, you know, the reason we have a formula is to make everybody's life easier. It's a relationship that always works, so you could try it, and, you know, that's the reason that there's formulas. It's a shortcut. So let's try one. Given line segment PS and line segment PT are secants. All right, if the measure of arc ST is 150 degrees, so I'm going to put that in the picture, and the measure of arc QR is 70, find the measure of angle P. Well, I am outside my circle of friends, so the shortcut formula is you subtract the 2 arcs, divide by 2. Is that it? That's it? It's that easy. So you get 120 divided by 2, so our angle is going to be 60 degrees. Easy, easy, lemon squeezy. Did I do that right? Oh, I subtracted wrong! Oops, my bad. 150 minus 70 is not 120, people. Did you make the same mistake? It is 80. 80 divided by 2 is 40. My bad. Whoops. All right, so I'm going to stop here because I'm about to run out of time, and we will pick up with part 2. Okay? Bye.